Okay, recording started. So welcome to the January 2nd study hall. If you are just watching this recording, then hello. Today's topic is maximizing and minimizing problems in the quant section. So again, just quick reminders. If you're here actually participating in this session, when we say give me a smiley face, we mean the smiley face here. When we say multiple choice question, go ahead and answer it. This is where you should answer the multiple choice questions. Also, copyright issue, we do need to give this citation, just copyright disclaimer. Unless we specifically say otherwise, the quant questions that appear in this session are courtesy of the GMAT prep software. In other words, not the official guide, but actually from the software that GMAT gives away for free. Important. All right, let's go ahead and start off with a problem. Go ahead and try this problem. Again, here's a timer. I'll give you a little bit more time than you might otherwise use on average, because this is a pretty long problem. And last but not least, don't forget where your multiple choice questions are located, where your answer choices are. So here's a timer. Have fun. Okay, this problem is evidently the craziness to end all crazinesses, because fewer than half of you have answered it yet. And it's been almost 3 minutes. So again, remember how this test works. If you are at all familiar with this, you know this, of course, but you can't not answer problems on this exam. So, in other words, there's no skipping things, there's no moving ahead or moving back. There's no revisiting problems once you've solved them. You get one crack at everything in order. That's just the way the test works. It works that way because it has to. You can't have an adaptive test that lets you revisit problems. But the long and short of it is that you can't. You can't leave things blank. So remember that you always have to answer every question. You have to respond to it. So if you haven't responded, there's still 4 or 5 of you who haven't. If you haven't responded, then it's not a thing. You can't do it. So just be aware. So here are your responses to the question. As you can see, there's kind of bimodal here. We've got lots of preference for B and D here. So nobody picked E, only one Lone Ranger picked A. Let's go ahead and check it out. So in any case, let's talk about what's going on here. So there's a lot of words here. We do have sessions on the idea of word problems in general. Like, we have sessions whose theme is to basically just talk about, what do I do when a word problem is placed in front of me? But let me just summarize that for your benefit and love here. The basic deal, if you want more information on this kind of thing across the board, go ahead and check out the sessions that are dedicated to word problems in the first place. But basically, when word problems are placed in front of you, when you have a word problem, the deal is that you want to read through the problem twice, because that's what we do in the real world. I mean, the reason why word problems, quote unquote, is not so bad on planet Earth is because we don't try to do everything all at once. Like, when we see word problems on good old planet Earth, what we tend to do with that is read it once just to figure out what the heck is going on, and then read it another time to actually figure out how to set it up. So, for example, if you're doing a spreadsheet for taxes, you don't make the spreadsheet and, like, halfway through that process, oh, let me start putting formulas in there. Like, you make the spreadsheet first. You make all your column headings. Here's all the stuff that goes into my spreadsheet, and then let's start doing crazy math with it. So, the first thing you want to do, the first read, is the first time you read the problem through, what you do is you don't do math yet. Instead, you just figure out what is in the problem and what's going on. I mean, that seems simple enough, but a lot of people are doing math so early that they haven't even really figured out what quantities are and are not involved in the problem yet. And if that's the case, you probably know that that's not the best situation in the world. So be aware to figure out what is even in the problem in the first place. And then whatever organizational device you want to make, that should happen in the first read. And I mean, basically to deal with word problems, just in case any of you guys find word problems consistently more difficult than non-word problems, if that happens, just as a heads up, the reason why that's happening is because you are not organized. It's not because word problems are harder. I mean, because in fact, the mathematics involved in word problems tends to be substantially easier across the board. But if you're having issues with those in general, just let me tell you the issue is organization. So first time, just organize the problem. Much more on this in the sessions that actually, in the Thursdays sessions that actually focus on word problems as a thing. But just be aware, this is the deal. Okay. So now that we got that out of the way, the second read is where you go back in your already organized type of setup. And then you do math. How about that? Math. M is for math. Yeah. So let's talk about this. I mean, how can you organize this just to... You don't have to be super amazingly brilliant about it, but does anybody have any suggestions for how we can organize this? I mean, before we even do that, let's answer the question of what's in the problem. So what's in the problem? Well, let's take a look, right? We have, I mean, someone said students and books. Depends on what you mean by that, because you wouldn't want to have like 30 different columns for 30 students. Yeah, number of students, number of books is more like it, right? So, because it's if you've ever taken a statistics class, you've seen this called a frequency distribution or whatever they call it. But you've got numbers of students that correspond to numbers of students. You have numbers of students who correspond to certain numbers of books borrowed. And then you also have, so we've got numbers of students who borrowed the same number of books, or who borrowed certain numbers according to the number of books that they borrowed. I mean, that's important because it's not, I mean, if you have numbers of students, you have to know what the numbers are. Well, total number of books have to be 60, though. That's not really a quantity that is manipulated. I mean, when I say what's in the problem, right now we're not talking about restrictions yet or conditions that have to be satisfied. We're just talking about things that interact with other things mathematically wise. So if that's not clear, my apologies for that. So basically what things could be columns or rows in a chart, or what things could go into formulas, or what things could, what things are doing math. The 60 is later. The 60 is going to be a restriction, but it's not what I'm talking about right now when I say what's in the problem. Instead, the other thing in the problem here is just how many books were borrowed by these students. So. And I mean, this is the first read. The first read, you're not even bothering to try to understand exactly what the math relationships are. There's no point yet. I mean, that's for later. Like right now, the first time is just kind of disjointedly looking through the words and just kind of seeing what's in there. So do that. It definitely helps. I mean, that seems weird to some people, but you're not really trying to do math yet. You're just trying to just look at this stuff and be like, what's going on here? So what's happening is you have numbers of books borrowed. Okay. Okay. So that's pretty much everything that's in the problem, is those things. So then we don't need the world's most elaborate chart for this kind of thing. I mean, we can just do that. We can just make a frequency distribution. So let's do it. Frequency distribution land. So we have number of books. And then we have number of students who borrowed that number of books. I mean, obviously, when you make your own chart, you're not going to have that many words in it. But my point here is to make a chart that everybody can understand. I mean, when you make your own chart, obviously, you should just make as much chart as you have to make for you to understand it, and for you to understand it for maybe 2 or 3 minutes. But, yeah, okay. Now let's talk about what we're doing here. So what is the maximum number of books that any single student may have borrowed? So what's kind of neat about today is one of those days when we can actually summarize the main idea of the study hall in a single sentence. It's kind of neat because, I mean, when we're doing a more complicated topic, complicated is the wrong word. When we're doing a topic that has more facets to it, we can't necessarily summarize the entire topic in a single sentence. But today we can, and just as a reminder, today's topic is the idea of maximizing or minimizing stuff. That's today's topic. Does anybody know, as soon as you are asked to maximize a thing, where should your thoughts go from there? Like, what do you really, right? You have to minimize all the other things. So very much across the board, this is where your thoughts should go when you see these things. So, general idea that we're going to focus on today. If you are asked to maximize one quantity, you need to think about how to minimize everything else, and vice versa. If you have to minimize one quantity, then you have to think about how to maximize everything else. So, I mean, it's cool because, again, it's not every day that we can summarize the entire takeaway from the whole thing in one sentence, but here we can. So, keep that in mind. That's going to be a repeating theme here. Because, I mean, that's how this stuff works, right? Let's say that you have a really busy day, but you want to, I don't know, stupid example, you want to maximize the time that you spend with your dogs, even though your day is busy. I mean, you know what this means, right? This means you have to do everything else as quickly and efficiently as you can so that you have more time with your dog. Hey, how about that? Pretty much common sense. But just make sure that you bring this stuff in, including common sense. Make sure common sense does not cease to exist when you have the GBAT in front of you. It's a more common problem than you might think. So, maximizing here, what are we maximizing? Well, we're maximizing the number of books that any student could have borrowed, which means one student. We want to give one student as many books as possible, which means that all of the other students have to basically share lots of books, and we want to minimize everybody except for a single student. So everyone's number of books except for one student. All right, that's what we're doing. So let's talk about what we already know. Also, here's a pretty good criterion for whether you are sufficiently organized or not. It's kind of a harsh criterion, but that's sort of the point. So here is a criterion that I actually use myself. So it's definitely a no bull kind of criterion. I mean, it's very black and white, which is what helps about it, and why I think it's useful. But a no bull criterion for whether you are organized here or not is once you've got all the information, once you have the information organized. If you ever have to look back up at the prompt, then you aren't organized enough. That's pretty much the deal. Like, once you have the information from the prompt in the form of whatever device, organizational device, usually a chart, but not always. If you have to look back up, it's a bad story. You don't want that. So, like here, we've got this. Now let's just make sure that we have the information from the problem. So we have a total class of 30. So let's make sure we note that this needs to add up to 30. I mean, obviously, you're not going to write that complete sentence on your paper that I just wrote. You're not going to write this column sum is 230, too many words. But you want to write something, sum equals 30 or whatever, that you're going to understand. 2 students did not borrow any books, so this is for 0 books, that's 2 people. And then once I realize what's going on in this problem, I would actually add another column to my chart, which would be, it's going to be number of books times number of students. Sorry, we had some migration there. If you do the number of books times the number of students per that number, then you're going to get total. So let me just add another column to the chart. So, and you can do that, right? I mean, people do it with spreadsheets all the time. Just add another column. You know, once you've made your spreadsheet, it doesn't have to be sacrosanct. So total number of books for this group. Total, I cannot write today, folks. Total number of problems, books for this group. Again, I mean, hopefully your labels will not have as many words or be as long-winded as these ones, but you get the point. So that would represent no books because it's not any books. With 2 students who borrowed nothing. Okay. So let's put that in there. And then we also are told that 12 students borrowed 1 book apiece. So 1 book per student times 12 students is 12. The rest of them borrowed, at least 10 students borrowed 2 books. 2 times 10. Is 20. And then the other thing that we have in there is that the number of books total. So this column sums to 60. And then how do we know that column sums to 60, by the way? Someone did write that in the chat box. That's what RS wrote in the chat box. So make sure you understand how that works. Yeah, it's average times, the average times the count is the sum of everything. I mean, this should actually be more or less an automatic reflex, right? Because that's in fact, it should be so automatic that whenever you see an arithmetic mean or average of absolutely anything in the world, you should pretty much instantly convert it to a sum without even thinking about it. So if you ever see an average arithmetic mean, just think average times count equals sum. So in this case, that's 2 times 30 is 60. And then once we have that, we can actually stop looking at the prompt. And again, our no bull criterion applies here, right? We don't have to look at this anymore because we don't there. And as long as we know that your goal is, I mean, you should be able to do that. I mean, you're not going to throw black ink on the screen during the test, but the point is that if they were to take away the problem from you at this point, if you are organized enough, it should not matter. So as opposed to verbal, where you're going to be looking back at things all the time. But here, if you're organized enough in setting up a word problem, you should not ever have to go back and look at it. So what we're doing now is, well, we have to minimize everyone else's number of books. So this is 24 students. So there are how many students left to think about? Chat box. There are 6 left. And one of those students is hogging books. So that means that we have to minimize the other 5. So let's do it. So we need to minimize 5 of the remaining 6 students' numbers of books. So I mean, if you picked, and also notice that you have 6 students left, and you have, this is 32 books, so you've got 28 books left as well. So if we take, so for 3 books is the least that those people can have. So we're going to give everybody 3 books, except for that last lucky kid who gets like all the books. And so that's 15. This is the least number of books that everyone else can have. And so then finally you have your one lucky student left over who, at least I'm a nerd, so I think that more books is lucky. But you got 1 student left. You use your sum of 60, so we know there's 1 student left because that's how we engineered it. But again, we know that because there's 30 students total. And now there are 60 books. So if you take all this away, this is 32, 47. If you take 47 away from 60, you need 13 books, which means that 1 student gets 13 books. And so that's D, dog. Okay, if you just got here, a couple people arrived. The reason why you saw black over the whole problem was, again, this point that's right here. If your organization is good enough, you shouldn't have to look back at the words. So that's why that was blacked out. General idea, you got it right here. If you need to maximize a thing, that really means you have to minimize everything else. I mean, so many things, right? Like if you're a sports team that has a salary cap and you want to pay that superstar player as much as you can, you know what that means. That means you're not so much trying to pay the superstar more as you are trying to pay everybody else on the team less. So that's the general notion of what's going on here. Any questions about this, feel free to put them in the chat box. If not, move on to another problem. Okay, because that problem wasn't so easy for people. I mean, no one's asking questions about it at the moment, but Michael B., I think you have text in your box. You've shown as having text in your box for the last, like, 15 minutes. So maybe you have a space in there or something, but if you could delete whatever's in that box, Michael B., would be awesome. It's looking like you're typing. Ginny is typing. If not, we'll move on to the next problem. See what Ginny has to ask here. Is there a way to solve this problem with a Venn diagram? Not really. I don't know how one would, because there's no overlap of anything here. I mean, 2 responses to that. The first is not really, because nothing is overlapping. I mean, we're only talking about one thing for each person, which is how many books they borrow. I mean, a Venn diagram would be for more than one criterion, Like, did they borrow books? And also, do they have dark hair? Okay, that could be that diagram. More to the point, Venn diagrams, you shouldn't really use them anyway. Because even if you do encounter a problem that uses Venn diagrams, you shouldn't use Venn diagrams. You should use double set matrix instead. If you don't know what that means, check out our guides under overlapping sets. But no, this is not there are no two overlapping ideas in this problem, so that wouldn't be an appropriate device. Okay, let's check out another one. Let's check out another one. All right, so this one is not from GMAC. This one is actually from Manhattan Materials. So there's your authorship disclaimer there. It's from stuff that is ours. Okay, try it. Don't forget where multiple choice answers are found. And I'll give you a timer. Here's a timer. That didn't work the first time. Okay. Boom, timer. Go for it. The answer choices are not there. Oh, dang it. Okay, let me find those for you. That is weird. I think I'm not sure what happened there. Because these are supposed to be single things, but oh well. Let's get you the choices for this problem. Sorry about that. Okay, so the choices for this problem are the following. Let me get you those. There they are. Just kidding, guys. Okay, so here are the answer choices to this problem. You probably already have a choice in mind, but I'll give you a little bit more time for that. Again, apologies. Okay. Here are your answer choices. Tyler, I don't know what you're implying there, but about our problems. Must be a Manhattan problem. Seems like fighting words. Okay. Seems like hate on the Manhattan problems. All right. Everybody pick something. Now that you actually have things to pick, haha. Everybody pick something, please. It's been a while, so you probably got something that is a thing. So, okay, we still got a couple non-responders. If your name is Janie or NL, please pick a thing that is a thing. And Harish, you had an answer. If you are Harish, you had an answer, and now you don't. That means you clicked it again. So remember, please don't click your answer twice. If you are Harish, go ahead and click it the third time. If you click the same letter twice, it'll actually unpick that letter. So, all right, well, this problem is apparently a beast, because if you look at this, there's absolutely no sort of consensus here at all. And in fact, the correct answer is one of the shortest bars on that diagram. So let's take a look and see what the deal is here. So, all right, well, list L, notice the list that's up there is not list L. The list up there shares certain items with list L. But let's just, what's going on in the problem? Well, I mean, the only thing you really have to notice right away is that we have a list of 7 things. So that's actually enough to organize. I mean, we can just make 7 blanks. So let's do it. Make 7 blanks. All right, good enough. Organize. Well, we have 7 integers. So that means we have 7 blanks. So here's a blank. Here's another one. There's 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 another one. I mean, it's really all we need. I mean, those blanks are sort of janky looking, but the point is that you don't need an elaborate organizational device if the problem doesn't solve one. So let's just say this is the biggest, and this is the smallest. Okay, gentlemen and ladies and gentlemen. There. I mean, that is an organizational device. I mean, again, organizational devices don't have to be big, elaborate contraptions. In fact, in most cases, it's better if they're not. So, all right, 7 integers. And then let's just see what we know. I mean, the median, the minimum, and the maximum are the same as these guys. So the minimum has to be 5, the median has to be 40, and the maximum has to be 200. So let's just put those in there. 5, 40, 200. And then the average is the same. So what else still remains the same if the average? Remember what is very closely tied in with the idea of average, arithmetic mean. The median we've got, so that's different. Yeah, but it's the total, right? The arithmetic mean remains the same. So the sum must also remain the same. I mean, just keep this in mind, right? I mean, when you see anything involving averages, we talked about this in the last item as well, but if you see anything whatsoever involving averages, let's lift this from the previous problem. Anything with average, arithmetic mean type of average, just think that. If you ever see that, just think about average times count equals sum. So like in this case, there's 7 things in both lists. So the sum is going to be whatever that average is times 7 in both instances. So that means you're going to have the same number as a sum of everything. So the sum here, I mean, that means the same sum. Now notice that you don't necessarily have to find what that sum is, because it might be easier just to think about how much things go up or down. So in other words, you can think about this in 2 ways. In one of 2 ways, which are, the first way is kind of, simpler but more work, which is you can actually calculate the sum of the first list. And then make this list have that same sum. Or, I mean, I don't like doing that much work because, let's be serious, I don't really like doing work. So that's not what I want to do. I would rather think about how much things go up and down, right? So if just note the decreases and increases from the first list. Because the sum has to balance out the decrease, the total of the decreases must equal the total of the increases. Because they have to basically cancel each other out. I mean, if you have more going down than up, you will not have the same sum anymore. You'll have less. If you have more going up than down, then you'll won't have the same sum anymore. So we can do it that way. So that way, that would obviate the need for actually calculating the sum, because who would really want to do that anyway, right? So, okay. Well, remember what the principle of the day is. The principle of the day is if you need to maximize a thing, you need to minimize all the other things. So let's put that on the board. That right there. That is the general idea of this topic. Okay. Minimize everything else. Also, I mean, the most popular answer here was E, 199. And, I mean, what's kind of weird about that is, I mean, because 199, it should be clear that's a trap answer. Because, you know, if your biggest integer is 200, your next biggest integer is not just going to be 199. Because this is the answer that you would get if you just don't notice anything else that's going on in the problem at all. You know, I mean, it's not going to work like that. You know, in other words, if I just told you there were different integers and the top one is 200, then the biggest this could be is 199. In other words, you would not have to think about minimum, you would not have to think about median, you would not have to think about average or sum or absolutely anything else that's going on at all. So even if you think that 199 is the answer, it's not. Just be aware of that. So, trap answer city. Don't do it. Don't pick it. Because again, anytime, to generalize, if you ever have an answer choice that like ignores 50% of the information in the problem, it's not the right answer. So the correct answer won't disregard most of the information given. Again, at the risk of being redundant here, what I mean by this is, if the problem were this, then you could still pick E. So that means that E is wrong. Just keep that in mind. If you mentally blank out a bunch of stuff and still get the same answer, then you know what that means. Okay, so remember you need to maximize, what are we trying to maximize? Well, we're trying to maximize the second greatest value in the list. In other words, the thing that is here. So that's supposed to be a maximum value. Which means that the real goal of this problem is to minimize the other stuff, i.e. this. Janine, no, it's a list of 7. It's just another list that has certain things in common with the list up there. So, but they're different lists. I mean, that list up there doesn't have a name. Like, you're not putting in another number. You have a totally different list of numbers that happens to have the same minimum, maximum, and median, but there you go. again, one piece of advice that I like to give people is that one of the most important principles is RTFQ, which stands for read the question. If you're wondering what the F stands for, of course, that stands for the full question. What else would it stand for? Okay, so, yeah. So let's talk about it. I mean, read it. If you have to read it more than twice, then of course feel free. I mean, if that wasn't clear, Janine, that you have a list of 7 things, then read it until it is clear. So we just want to make these as small as we can. So we need 7 different integers. So what are the smallest numbers that could go in these 3 blanks? Yeah, we need, what about negative integers? Well, your minimum is still 5, so you can't have those. Okay, so 6, yeah, I mean, the smallest that you can get here is 6 and 7, because those are, you have to be more than 5, right? So 6. So, and then median still has to be 40. So the smallest that can be in that blank is 41. Again, you could sum this all up. I mean, I suppose it's not that hard, but I would rather just figure out ups and downs. So this is 4 less than what's up there. This is 13 less than what's up there. This is 40 would be 40 less than 80, so this is 39 less. So remember, we have to cancel these all out. So because we need the sum of everybody to be the same. So this is a total of 17 and 39 is 56 less. So we need this number to be 56 more than it used to be. So that's 120 plus 56. And so that's A. The biggest that you can have is 176. You can also just add these up. If you add these up, it's what? This is 200, so 400. 475 is the sum. And then you could just subtract 5 and 6 and 7 and 40 and 41 and 200 from 475, and you will get 176. So again, this problem was apparently the beast of all beasts, because of all the people here, only like 3 or 4 of you got it right. But notice again, I mean, when you get problems like this incorrect, make sure that you understand why you got them incorrect. Because, I mean, one thing that is probably very clear here, or at least it should be very clear, is that no one in this room is going to get this problem wrong because of math. Right? The only math in this problem is quite literally second grade math. I mean, you're subtracting small-ish integers. So that's not the issue. The issue is you might not have been organized. I mean, maybe you just didn't make 7 blanks. Okay, well, the next time do it. Messy calculations, I don't really think it's messy. I mean, it's in point of fact, it's not messy. I mean, the messiest you could get would be if you had to add these numbers and make 475, and then take these away from that. I mean, that may not be something you can do in your head in 5 seconds, but that's not the same thing as messy. I mean, you're not doing crazy long division of decimals. So, can the missing numbers be 5, 5, and 40? No, they can't, because remember RTFQ, people, which stands for, of course it stands for read the full question. They're not the same. Okay. There should be Is there a thought process for this kind of question? I mean, the best response I've got to is there a thought process for this kind of question is what's already on the board, namely that. That's a thought process for this kind of question. Beyond that, I don't see where you're really going with this. But the point is when you miss a problem like this, you really have to go back and revisit the problem and figure out why you missed it, because you didn't miss it for any sort of math-related reason. You missed it because either you weren't organized, or you didn't have a goal, or whatever sort of background type of missing element like that. Because, I mean, organization here is pretty easy. All you gotta do is make 7 blanks. But even that, weirdly enough, will get people, because some people don't make 7 blanks. Okay. I mean, next time, make 7 blanks. But just make sure you do it. How did you know you had to create your own list? Because list L is not that list. That's how you know that. I mean, some of the things are the same as that list. Like, once you see these words, in other words, what happened? Okay, once you see these words that are purple underlined right here, I mean, those words also imply that list L is not that list. I mean, otherwise you can't have, if certain things are the same as the list above, then it implies that we are not talking about the list above, because otherwise you couldn't have things that were same or different. So that, again, it's RTFQ again, people. Do not rush the process of R-ing TFQ. I mean, if you need to go through the question slowly, then go through the question slowly. So, yeah, see, Nadia is now R-ing TFQ, and suddenly it makes a lot more sense about that. Okay, let's move on if there are not more questions about this. A couple of you guys are typing. But again, I mean, it's also a humbling experience. I mean, only about 2 or 3 people got this right, even though it's a question that involves no more than 2nd grade math. So that's kind of a good thing, the sort of humility factor there. So, all right. Well, yeah, fine, but that sort of complaint of I'm not sure if I'll get it, I mean, that's always a thing. And remember, the test is adaptive. I mean, even people who are scoring near the top of the scale are still going to miss almost half the problems they see. So it's really not a big deal. I mean, you win some, you lose some, and that's kind of how it goes. So, and no, practice will not lead to perfection. Really, no, it will not. I mean, this is not the kind of test where perfection is a thing at all. No, absolutely not. I mean, everybody will miss lots of problems on this exam. Everybody. It's actually the point. But that's why the test is the way it is. It's why it's adaptive, and it's why there are so many items on the exam. Because everybody is going to get lots of things wrong. If you are thinking about perfection, you're going to get destroyed. You're just going to get tossed out the door. I mean, you're gonna miss a lot of stuff. It's going to happen. So be ready for it. Not kill joy either. I mean, honestly, perfectionism is what kills joy. I mean, there are plenty of studies out there showing that perfectionism is actually worse for you than alcoholism. So, in terms of inhibiting your ability to do things. Very true. So if you are the type of person who is like, oh my God, I have to get everything right, then you should kind of get rid of that in general, because it's very limiting. So yeah, exactly. People who score 700 get about 18 problems. I mean, that's just on the math section too. That's not even the whole test. Okay, so let's keep going here. Let's do another problem. All right, how about this guy? This one's from GMAT Prep. Again, RTFQ, do not slow. Thanks, I appreciate that. Do not speed up the RTFQ part of this. Here is a timer. That's where your multiple choice answers are found. Do it. Okay. Maybe take 30 more seconds. You guys can see the choices, right? Because there's not a lot of people answering this thing yet. Okay, they're there. So take maybe 30 more seconds, not much more than that. We'll give you a little more time. But if you're lost, throw it, pick a thing. If you're finishing up, finish up. All right, we still have 1, 2, 3, 4, 5, 6, 7 non-responders. So that's not really acceptable. All right, that's better. Go ahead and pick something that is a thing. All right, so if your name is ANDS3, Derek, or Rahul, I think a couple of you just shut up. But if you have been here for this duration of this problem, then just go ahead and pick something. All right, so here's what you picked. There, all right, so we have a plurality for B. It's not a majority, but at least there's some signal in the noise this time. So, but let's discuss. So, what's going on here? So, like again, the first read should be just what is even going on here in the first place, not to worry yet about doing specific mathematics. First read, what's happening? Okay, well, let's answer what's going on here. So, you have 11 districts. By the way, yeah, so you have 11 districts and 11 districts, and that means you want to minimize, rather, yeah, you want to minimize one district. So you want to basically make one district as desolate and as unpopulated as possible. You want to minimize the population of one district. So what does that mean you're really doing in this problem? Again, here's the general principle. What do we have to do? How do we have to do that? How do you minimize the population of one district? You have to max out all of the other ones. Exactly. So the point is that you need to, therefore, you need to maximize the population of all the other districts. Okay. And also, the deal is that in this problem, the populations are not different. They don't have to be different numbers. And there's absolutely nothing distinguishing districts from each other, which means that all of the other maximum districts are going to have the same population because there's no reason why they wouldn't. So in other words, there's going to be some maximum allowable value, and in this case, every single other district is going to have it. So all of the other districts will have the same maximum value of population. So what that means, and you want to figure this out before you start doing mathematics. So because then we don't need as much. I mean, we're not going to have 11 blanks in an organizational chart. And I mean, again, when you go over this stuff, make sure you realize that they will be reasonable. What I mean by that is, I mean, 7 blanks, like this last problem that we saw, which had 7 blanks for reasonably small-ish numbers. Like in this problem, it's perfectly reasonable to have 7 different blanks because these numbers are not that big and there's only 7 of them. But they're not going to give you a problem where you have, so much arithmetic that it butts up against the time limit just doing the arithmetic. So they're not going to give you 11 blanks with numbers as large as 132,000. It's not going to happen. So in other words, if you're making 11 blanks, you should probably reconsider whether that's necessary. So, but okay, so we have, let's just say we have our minimum district. And then we have 10 other districts. So, and then what we have to do is we're going to have a population per district. That is a very unsightly line. And we are going to have a total population as well, because we know that the total population has to sum to 132,000. So let's say population per district. And then total population. And then the sum of these total populations is going to be 132,000. And also these two are going to be the same, right? Like these, because this is only one district. So this box will be the same number as that box. Whatever is in those two boxes will be the same. So the point is that this is one district. One way to do this problem is to do algebra. And when it says no more than, let's also note that no district can have more than 10% over another district. I mean, we are trying to minimize the top row, thus implying that we want to maximize the stuff in the bottom row. So what that means, if you have an upper limit of 10% of the thing in the top row, 10% over, then you want to make it exactly 10% over. Because again, you're trying to minimize this, which means your goal is to maximize that. So, we wouldn't want less than 10% increase, because then we wouldn't be maximizing. So this is going to be an increase of 10% more. Okay, there is our organizational device. Now notice that we totally don't need, and as soon as we realize that this slightly shaded part here that's the goal. The goal is to find that. Once we realize that, we don't need to look at the problem again. So we can actually take this to an entirely new screen in order to talk about approaches. So here is the organizational device that we made. Let's say that we wanted to do an algebraic approach to this. You don't have to, but you certainly can. Then probably want to put our variable in that column somewhere. So this is a 10% increase from here to actually the 10% more should be not there. It should actually be here. So let's kill that from where it is at the moment. Yeah, all right, that's better. So the 10% more is going to be there. All right, let's reconstitute that diagram. Okay, there we go. So if you want to put a variable there, you can certainly do that. in general, reversing percent changes is extremely annoying. So you wouldn't want to put x here. Because if you put x here, notice this would be like x divided by 1.1. It would not be 90% of x. If that's unclear, then there are percentage study halls that you can watch too. But if we put an x here, I mean, percent increases over a certain amount are not that bad algebraically. So just in case you don't know the shortcut for that, it's 10% more than x, which means that you are taking x and you are adding 10% of it. So that's 1.1x. Eventually, I mean, percents are not the focus of today, so I don't want to go into this too much, but eventually you should get to the point where you can just do times 1.1 for a 10% increase and not have to think about actually adding 10%. But if you're not there yet, that's fine. So this would be 1.1%. 1.1 times, which represents 10% more. And so then you have total populations of respectively x and 10 times 1.1x, which 10 times 1.1x will give you 11x. So the sum is 132,000. So 12x is 11x plus 1x. 12x is that number. If you don't, I wouldn't know these numbers off the top of my head, so I would just have to do long division. So if you have to do long division, don't try to not do long division. I mean, if you have these numbers memorized in your head, then good for you. But if not, don't waste your time staring at it. Just do the division. So 12 goes into that one time. Take out 12. That gives us 1. And then that's beautiful, because then that's just another 1. 12, nothing left. And then everything else is zeros. And so x is 11,000, and that's the answer that we want. So, boy, except for that, yes. Wait a minute. I'm being dumb. What am I doing here? X plus 11x. I'm not being dumb. Okay, there we go. So 11,000 is the minimum possible population for the district. Okay. So of the given answer choices, which are on the previous page, that is choice D, dog. Does anybody know, let's take these answer choices over to the next page. Does anybody know how you can do this problem in a way that is not algebraic? Remember that the most important goal here, effectively the only goal that you really have when you review these problems, is to have as many ways as you can of solving them. So can anybody think of a way? Yeah, you can back solve. If you don't know what backsolve is, then you really should. If you don't know what backsolve is, then check out the study halls that are entitled flexible problem solving or backup methods, that kind of thing. But basically, backsolve just means throw in the choices. Try an answer choice, just toss it in there, and do whatever work you possibly can do. And then basically once you do that work, the problem will either work or it won't work. And that's pretty much the story. And so when you, let me erase the long division word so we have more room. I mean, yeah, when you back solve, it's either going to work or it's not going to work. It's a pretty nice dichotomy there. So just do whatever work you can and then see if it works. If everything works out together, then you win, and if not, then you don't win. So back solve, throw in an answer choice. Do whatever work you can with the given conditions. And then if everything works, you win. Also, remember what you're looking for in this problem. You're looking for the minimum, which means you would want to start from the lowest number. Because like if you plug in a random number and it works, then that doesn't mean it's the minimum. So you in this case you would not want to start at the middle. You would want to start with lower end numbers. So let's try A here and see how that works out for us. So in green we'll try A. That means that this is 10,700, which means the total population of 10,700. 10% more is going to be plus another 1,070. So that's going to be, I mean, I would do this work in another place if I had scratch paper, but I don't have scratch paper, so that's 11,770. That's 11,770. So that's going to be 10 districts with that population. So that's going to be 100. And let me make the chart accommodate those numbers. That's better. Okay. 117,700. And if you add these, I mean, you don't have to go through the entire addition process because you can tell that it's less than this, too small. So, because this is less than 11,000, and if you added 11,000, you'd still only have 128 something. So it's not going to be big. So it doesn't work with A. If we do it with other choices, we can just keep going until we win or lose. If we try B, it's 10,800. That's going to be 10,800 plus another 10%. Which is 11880. So this is going to be, Pravin, you would get lucky in this problem that way, but remember you want the minimum value. So if you plug in the middle value and it works, that does not mean the middle value is correct in this problem. So you're not really, I mean, you're only eliminating 3 choices if you get lucky that way. Because if I plugged in C and it worked, I would still have to try B and A. So this is not a find the result problem. This is a find the minimum result type of question. It's a different story there. So picking the middle number to start with is not an advantage of this problem. Okay, so still too small. We're still under 129 something. So that's not going to work either. And again, that was B. So B is out. If we try C, and I mean on your paper this would certainly work a lot faster than my computer screen because let's be serious. Making charts on a computer screen, not that great to start with, and Ron is terrible at computer. So, okay, in case you're worried about time, this is not a very long process. So 1090 plus 1090 is 11990. And so that's going to be 119900 and 1090. That's still too small because if this were 11,000, then you would have 13090, and it's even less than that. So it's still too small. And so then we can pick D like dog. If we do that, I mean, and D is kind of a nice number in the first place. I mean, I might gravitate toward D in the beginning just because it's such a nice number. 11,000 plus 1100, which is 1210. So that's 11,000. That's 121,000. And that gives us 132,000. And we win. So it's D. Good stuff, ladies and gentlemen. Okay, so we are done. I suppose this topic, we have a couple more problems lined up. So we might just continue this theme into the next study hall, at least for the first half of it or something. So thank you. And again, remember that when you are doing review of these kinds of problems, this is your goal. Your goal is to find as many ways as you can find. Your goal is not to think about easiest or fastest or other similarly meaningless things. The goal is to come up with the maximum number of possible ways to solve these things. Okay. Let's go ahead and quit. So, do you have any quick business-related questions? The next session is, I believe, in 2 weeks. They are normally separated by 2 weeks. We've had the last couple in consecutive weeks, which is a relatively unique situation. But go ahead and check the Thursday's webpage because it'll be up there. The next session will be up there by tomorrow or whatever. So, well, Kumi, you don't have to do these problems in 2 minutes. I mean, remember that 2 minutes is an average time. And remember how averages work. I mean, it's an average. I mean, these problems are clearly longer than average problems because, you know, they have like 3 times as many words as most problems do. So, yeah, you don't need to do that. I mean, these problems can take 3 minutes very easily with no issues, maybe a little bit more. The point, though, is just that if you're lost, you should quit. I mean, if you're lost after 20 seconds, you should quit after 20 seconds. If you're still doing productive work after longer than that, then you should keep working. So, all right, we're going to kill the recording here. I'm going to start hustling you out in a second, but thanks.